Sections 4.3 and 4.4. Day 1 is just the factoring part. So what I want you to realize and make sure you're making the connection of is that when we factor y equals ax squared plus bx plus c, this is a function in standard form, and we're going to a function that's going to look like intercept form. And so you need to make sure that you're making that connection. And now these 5 steps, though I do want you to write them down, might seem somewhat complicated, but that's why we're going to do a whole bunch of problems to illustrate them. So the first thing you should always do whenever you see a quadratic or any kind of polynomial actually, especially if you're going to try to factor it, is to factor out a GCF, a greatest common factor, from all of the terms. Now this isn't always possible, but if, for example, they're all even, then obviously you want to factor out a 2. So you factor out the GCF. Next, you want to determine what two numbers will multiply to equal the A times C product that also add to equal that B coefficient. And then you're going to use these two numbers to rewrite the BX term as two separate terms. So we're actually going to be going from a trinomial, something with 3 terms, to something with 4 terms. Then we're going to factor out the greatest common factor of just the first 2 terms. So you're going to have a GCF, and then in parentheses you're going to have a binomial, 2 terms in there. And then you're going to factor out the GCF from the second 2 terms. So again, you're going to have a factor outside of the parentheses, and then what's left inside the parentheses. And what's left in both of those sets of parentheses should match. And then you're going to set up 2 sets of parentheses, one that contains the GCFs and one with the matching leftovers. And so now let's go through these steps. If we have 2x squared plus 28x plus 96, the first step is to see if there's a GCF. Well, they're all even, so we can factor out a 2. And so then what's left? So 2 times what would give me 2x squared? Well, that's just going to be the x squared. And then 2 times what would give me 28x? Well, that would be 14x. And 2 times what gives me 96? That's 48. So now we're going to look at our A times C. So keep in mind that my A is 1. So my A times C is 1 times 48. And my B, so 48. And my B then is this middle term, which is 14. And so now sometimes the 2 numbers that will multiply together to give you 48 that also add together to give you 14 will just pop in your head, and if they do, that's fantastic. If they don't, if you list all the factors of 48, so let's do that. 1 times 48, does 2 go into it? 2 times 24, does 3 divide into it? 3 times 16, does 4? Times 12, does 5? 5 doesn't divide evenly into 48. Does 6? 6 times 8. Does 7? 7 doesn't divide evenly into it. And now since the next number we would be asking is 8, and I've gone through these looking at every single number, once I get to the point where I would start asking for these numbers again, I know I have all of the factor pairs of 48. And so then we're going to look at which factor pairs add up to give me 14. And we can see that that's going to be 6 times 8 and 6 plus 8. So now we're going to rewrite this 14 as 6x plus 18 or 8x, and then keeping the rest of it. So we haven't changed our quadratic. 14x is the same as 6x plus 8x. So now we still have that 2 out in front, so don't forget that because that is a factor. We're going to look at the first 2 terms. What do the first 2 terms have in common? They have an x. And then what will be left over if we factor out or take an x out of both terms? We'll be left with x plus 6. And now we're going to look at the last 2 terms. What can we factor out or take out of both 8x and 48? Well, they're both divisible by 8. And what are we left with? Again, x plus 6. Now, we can look at these as 2 terms, and so what could we factor out of both of those terms? Well, they both have an x plus 6. So we're going to take that x plus 6 out. If we then kind of cross that out because we factored that out of both of those terms, what are we left with? We're left with an x plus 8. And so this would be my final answer. This would be factored form. You could also see how this represents intercept form. So let's take a look at a few more. 3x squared minus 10x plus 8. Well, first of all, when we look at 3, 10, and 8, there is no GCF. So we're going to jump right to a times c. Well, my a is 3 and my c is 8, so my a times c is 24, and my b is negative 10. So again, if I think about some of the factor pairs, I can think that 12 times negative 2 would give me, would add together to give me a negative 10. Nope, they wouldn't. That would give me a negative 24 and a positive 12, positive 10. 6 times 4, well, that multiplies together to give me 24, but it doesn't add together to give me a negative 10. How about negative 6 and negative 4? Two negatives will give me a positive 24, and when I add them together, they're going to give me a negative 10. So those are the two numbers that I'm going to use to break apart that negative 10x. So 3x squared minus 4x minus 6x plus 8. And it doesn't matter what order you write that 4x and 6x, so we could have written it as negative 6x and then minus 4x. So again, taking a look at the first two terms, I can factor out only an x, and I'd be left with 3x minus 4. And so now keep in mind we've said that we need to end up with a 3x minus 4 because my parentheses need to match. So what can I multiply 3x by to give me negative 6x, and what can I multiply negative 4 by to give me a positive 8? Well, it's going to be a negative 2. And so again, realize that if I were to multiply these back together, I would end up with that polynomial above. So again, what's in common with both of these terms? Well, the 3x minus 4. And then if I cross those out, what am I left with? X minus 2. So again, that's my factored form. Moving on to the next one. X squared minus 9x minus 5. And so there's no GCF. And so now we're going to look at our a times c. Well, my a times c is 1 times negative 5. And my b is negative 9. Well, the only thing that can multiply together to give me 5, or negative 5, is going to be a 1 and a 5. And I can't add those together to give me negative 9. So this one cannot factor. And moving along, negative 12x minus 2x plus 30. So it's always going to be a lot easier if your a term is going to be positive. So if we look at negative 12, negative 2, and 30, we could factor out a negative 2. And then I'd like you to pause and write down what you think you'd be left with. That's going to be negative 2 times 6x squared would give me negative 12x squared. Negative 2 times a 1x would give me negative 2x. And negative 2 times negative 15 would give me a positive 30. And so now again, we're going to look at our a times c, which is 6 times negative 15, or negative 90, and my b, which is 1. Now this might seem rather difficult because negative 90 is a big number, but if you think about the two numbers need to add together to give you a 1, they're going to have to subtract because this is a negative 90, and to add together to give me a 1, they can only be different by 1. So what should come to mind is 9 and 10, and which one's going to have to be negative to give me a positive 1. So it's going to be a positive 10 and a negative 9. So again, we're going to rewrite our 1x as plus 10x minus 9x. And then still looking at the first two terms, a reminder that negative 10x minus 9x is 1x. But now looking at the first two terms, 6x squared and 10x, what can we factor out of both of those terms? Well, they're both even, so we can take out a 2, and of course they both have an x. And then we'll be left with 2x times 3x would give us 6x squared, and 2x times 5 would give us the 10x. And again, I need to have that same thing in my parentheses, the 3x minus 5. And so sometimes if you write down what should be left, it's a little bit easier to see that we should factor out a negative 3. And then again, the 3x plus 5 we have in common. Don't forget that negative 2 that's out in front because it is an important factor. If we cross those out, we're left with 2x minus 3. So a reminder that as we're doing this, we're going from standard form to an intercept form. And so I could find the intercept by setting both of those in the parentheses equal to 0, and that's going to tell me where this parabola would cross the x-axis. Okay, so negative x squared plus 3x plus 18. As I said, it's going to be a little bit easier to factor these if your a term, your leading coefficient, is positive. So let's factor out that negative 1. And all that does is change the signs of everything inside the parentheses. So again, my a times c and my b. And if we look at the factor pairs of 18, we can see that we're going to need to use a 3 and a negative 6, because in order to multiply together to get a negative 18, one of the factors has to be negative. And so then that's when we look at our b term to help us determine which one is negative. So since it's got to be a negative 3, it's the negative 6 that's going to have to be a negative. Since my b is a negative 3, I mean. So we are going to rewrite my negative 3x as 3x minus 6x. Again, those are equal to each other. And then we're going to look at the first two terms. The only thing I can factor out is an x. I'm left with x plus 3. And then if I write that x plus 3 down again, it should be a little bit easier to see that you're going to have to factor out a negative 6. X plus 3 is a factor, and what's left is x minus 6. So there's 3 more examples that are just regular factoring of these trinomials. I would like you to maybe pause the video and go through and do those, and then make sure that you got the right answer, and then come back and there's one last thing that we need to check. So again, a GCF, and that's what would be left. My a times c is 4, and my b is negative 7. Well, there's nothing that I can multiply together to give me 4 that's going to add together to give me a negative 7. So that would be my final answer. It can't factor any more, so don't write that this can't factor, because we did factor out a 3. It just can't factor anything more. And then the last two, there's no GCF. My a times c is 20, my b is negative 12. I'm going to have to use negative 2 and negative 10. And if you're still not understanding how to come up with these two numbers to get what multiplies together to give your a times c and your b, please make sure you come to class and ask that. So then as we write these out, and the last one of these, again, no GCF. Writing out all of the factor pairs, I can see that the only thing I'm going to have to use is 4 and 9. And in order to get a positive 5, the 9 is going to have to be positive. Rewriting my trinomial, and then factoring both parts. Okay, so the difference of two perfect squares, a squared minus b squared. You have to be familiar with your perfect square numbers. These should be relatively familiar to you. These are also perfect squares. And so when we go to factor something like 9x squared minus 64, the square root of 9x squared is 3x, and the square root of 64 is 8. And the important thing is here that it has to be the difference of perfect squares. If this was 9x squared plus 64, we could not factor it. And so then we're going to set up two parentheses, 3x plus 8 and 3x minus 8. And we're done. It doesn't matter which order you have, the plus or the minus. And then finally, if you recognize that the 4 is a perfect square and the 25 is a perfect square, and you can add those square roots, multiply and add those square roots together to get the middle term. But if you don't, your a times c is 100, your b is 20, so 10 times 10 and 10 plus 10. You can still do this the way we've been doing all of them. Break apart your middle term, factor what you can out of the first two terms, factor what you can out of the last two terms, And then when we set up our two sets of parentheses, you'll see that they're actually the same, so that we can write it as 2y plus 5 quantity squared. And this is going to become useful later down in the chapter when we are solving equations by taking square roots. Alright, so remember to please go back and do the notes check, write down any questions you might have, and we'll see you tomorrow in class.